Hi students, today I am going to explain the exercise 12.2. The chapter name is Area Related to Circles for Grade 10 Ncert textbook. First question, find the area of a sector of a circle with radius 6 cm if the angle of sector is 60 degree. Here our question is find the area of a sector of a circle with radius 6 cm if the angle of sector is 60 degree. We know the formula area of sector equal to theta by 360 into pi r square. Here theta is the angle made by the sector and radius is the r is the radius of that circle. So theta is the angle and radius r is the radius. So area equal to, the formula is area equal to theta by 360 into pi r square. You substitute. For theta it is 60 and 3 by 360 into 22 by 7 into 6 square. After simplification we will get 132 by 7 centimeter square. Next question. Find the area of the quadrant of a circle whose circumference is 22 centimeter. What do you mean by quadrant? When you divide a circle into 4 parts, we will get a quadrant. So quadrant means the 1 by 4 part of a circle. Quadrant is the 1 by 4 part of the circle. That means if you divide the circle into 4 parts, we will get a quadrant. The angle of quadrant equal to 90 degree. The angle of quadrant is 90 degree. So here the area of quadrant of a circle whose circumference is 22 centimeter. Therefore the quadrant is a sector. So we can use the formula for area equal to theta by 360 into pi r square. But here theta is given but note r is not given. So from the circumference, it is given that circumference is 22 centimeter. So from the circumference you can calculate radius. Here circumference is 2 pi r equal to 22. It is given. So 2 into, you substitute 2 into 22 by 7 into r equal to 22. Therefore r equal to 22 into 7 by 2 into 22 is equal to 7 by 2. So we got r equal to 7 by 2 centimeter and theta we know it is 90 degree. So you can substitute area equal to theta by 360 into pi r square. So 90 by, why it is 90? I told you a quadrant means when you divide a circle into 4 parts, we will get quadrant. The angle of quadrant is 90 degree. So here theta is 90 degree. So 90 by 360 into 22 by 7 into 7 by 2 into 7 by 2. It's equal to 77 by 8 centimeter square. Now third one. The length of a minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. The length of a minute hand of a clock is 14 centimeter. That means that radius of the circle, it take us the radius of the circle. It is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So in 5 minutes means this 12 to 1. The angle is 30 degree. You know 12 to this is a complete angle. Complete angle is equal to 360. To get the one angle, that means the angle between two numbers, to get the angle between two numbers, you divide 360 by 12 because we divide the whole part into 12 divisions. So to get one division, you divide 360 by 12, you will get 30. So between two numbers, the angle is 30. For 5 minutes, the angle is 30 degree. 4 minus the angle between two numbers is 30 degree in a clock. So here find the area swept by the minute hand in 5 minutes. So this is the angle and you take this as a sector and find the area of that sector. We know the formula area of the sector equal to theta by 360 into pi r square. Here radius is given as 14 centimeter and theta equal to 30 centimeter. So area we can write, theta equal to 30 degree. The angle between two numbers in a clock is 30 degree. So theta equal to 30 degree. You substitute and simplify. We will get 154 by 3 centimeter square. Our next question. A chord of circle of radius 10 cm subtends a right angle at the center. Find the area of the corresponding minor segment and major sector. So, you have to find out the area of the minor segment and area of the major sector. So, a chord of circle. This is AB is a chord. Subtend a right angle. That means it makes angle 90 degree at the center. Find the area corresponding minor segment. Here this is the minor segment. This is minor sector. This full portion is the minor sector, but this shaded portion is the minor segment. So to get the minor segment, you first find the area of this minor sector and then find the area of this circle and subtract. So to get the area of the minor segment, first you find the area of this minor sector and find the area of this triangle and you subtract. So the formula for area of a sector equal to theta by 360 into pi r square. Here radius is 10 centimeter and angle is 90 degree. So area of minor sector equal to 90 by 360 into 3.14 into 10 into 10 equal to 78.5 centimeter square. So we got the area of the minor sector as 78.5 centimeter square. And what about the area of the triangle? We know this is a right angle triangle. So you can take this as base and this as height. So you can use the formula area of the triangle equal to half into B into H. That means half into OA into OB equal to half into 10 into 10 is equal to 50 centimeter square. So now you got the area of the triangle and area of the sector. You subtract the area of the triangle from the area of sector, you will get the area of minor segment. So area of minor segment equal to 78.5 minus 50 equal to 28.5 centimeter square. Now our second part is find the area of the major sector. Major sector means this is the minor sector. This part is minor sector. The remaining portion, this is the major sector. So to get the area of the major sector, you subtract the area of the minor sector from the area of the circle. Again I am telling, to get the area of the major sector, you subtract the area of the minor sector from the area of the circle. For this, first you find out the area of the circle. So area of the circle, we know the formula, it is pi r square. That's equal to 3.14 into 10 into 10. This is equal to 314 and you subtract the area of the minor sector. Minus 78.5 is equal to 235.5 centimeter. So area of the major sector equal to 235.5 centimeter square. Fifth one, in a circle of radius 21 centimeter, an arc subtend an angle of 60 degree at the center. Find the length of the arc, area of the sector formed by the arc, area of the segment formed by the corresponding chord. So, first you have to find out, here there is one circle of radius 21 centimeter, an arc, this AB subtends an angle of 60 degree at the center. Find the length of the arc. That means you have to find out this length AB. This arc length you have to find out. We know the formula. The length of the arc equal to theta by 360 into 2 pi r. The length of the arc equal to theta by 360 into 2 pi r. The area of the sector is theta by 360 into pi r square. And the arc length of the circle equal to theta by 360 into 2 pi r. The pi r square and 2 pi r is the difference. So here the length of the arc equal to theta by 360 into 2 pi r. Here r, it is given as 21 centimeter and theta is given as 60 degree. So 60 by 360 into 2 into 22 by 7 into 21, we got it as 22 centimeter. So the length of the arc is given as, the length of the arc we got as 22 centimeter. Now second one, area of the sector. Area of the sector, we know the formula, theta by 360 into pi r square. So 60 by 360 into 22 by 7 into 21 into 21 equal to 231 centimeter square. So this is the area of the sector. Now area of the segment formed by the corresponding chord. That means area of the segment means the area of the segment is this. This you have to find out. In the previous problem, we found that first you found the area of the sector and then area of the triangle and you subtracted, then you got the area of the minor segment. Here also we can use that method to get that area of this minor segment. First you find the area of the sector and find the area of the triangle and you subtract. But here is one major problem is this. Here this is not 90 degree. If it is 90 degree, you can use the formula half into b into h directly. But here there is no base and there is no height. To get the area of the triangle, we need height and base. But here there is no base and there is no height. So you have to find out the height and base. For this, what we will do? You take this triangle. And you draw OM perpendicular to AB. OM is a perpendicular bisector to this AB. OM is perpendicular bisector. So this 60 divided into 30 and 30. 30 degree and 30 degree. And this AB divided into equally AM and MB. So to get the area of triangle AOB, first you draw OM perpendicular to AB and you take this triangle. In triangle AOM, cos 30. Cos 30 equal to what? Cos 30? Cos 30 is equal to adjacent by hypotenuse. This is 90 degree. So this is hypotenuse. And considering this 30 degree, this OM is the adjacent. So cos 30 equal to OM by OA. So cos 30, the value of cos 30 is root 3 by 2 and it's equal to OM by OA is given as 21. So OM by 21. So OM equal to 21 root 3 by 2. So OM we got 21 root 3 by 2. So this is the height of the triangle. Now to get the base, you take sin 30. Sin 30 equal to here AM, opposite side is AM and hypotenuse 21 centimeter. So AM by OA is equal to AM by 21. And you know the value of sin 30 is equal to 1 by 2. So 1 by 2 equal to AM by 21. Therefore AM equal to 21 by 2. So we got the half of the base. But we need the base. We need AB. So AB equal to 2 into 21 by 2. It's equal to 21 centimeter. So we got AB as 21 centimeter and OM as 21 root 3 by 2. So this is height and this is base. Now you can use the formula half into BH. So area of the segment equal to area of the minor sector minus area of the triangle AOB. So area of the minor sector we already got it as 231. So 231 minus 1 by 2 into 21 into 21 root 3 by 2. And here 231, 21 and 21 is equal to 441 divided by 4 root 3. So this is the area of the segment formed by the area of the minor segment or area of the segment formed by the corresponding chord. Sixth one, a chord of circle of radius 15 centimeter subtends an angle of 60 degree at the center. Find the areas of the corresponding minor and major segment of the circle. So here a chord of circle of radius 15 centimeter subtends an angle of 60 degree at the center. Find the areas of the corresponding minor and major segment of the circle. So to get area of the minor segment, first you have to find out the area of the minor sector and the area of the triangle and you subtract it. So area of the minor sector equal to theta by 360 into pi r square. Here theta is given as 60 degree. So 60 by 360 into 3.14 into radius is given as 15. So 15 into 15. So we got as 117.75 centimeter square. So we got area of the minor sector as 117.75 centimeter square. Now to get the area of the triangle, we can use the same method that we used in the previous problem. Here draw OM perpendicular to AB and take this triangle. In triangle OAM, find cos 30. Cos 30 is OM by OA. Cos 30, the value is equal to root 3 by 2 is equal to OM by 15. Therefore OM equal to 15 root 3 by 2 centimeter. So we got height OM is 15 root 3 by 2 and take sin 30. Sin 30 is equal to AM by OA and substitute the value 1 by 2 equal to AM by 15. So AM we got as 15 by 2 and we need the base as AB. So to get AB, multiply by 2. So AB equal to 15 centimeter. So substituting the formula, area equal to half into B into H, half into OM into AB, it's equal to half into 15 by 2 root 3 into 15, it's equal to 225 root 3 by 4. So we got the area of the triangle as 225 root 3 by 4. So to get the area of the minor segment, you subtract the area of the triangle from the area of the minor sector. So area of the minor segment equal to area of minor sector minus area of triangle AOB. When you subtracting, you will get 20.4375 centimeter square. So you got area of the minor segment equal to 20.4375. Now to get the area of the major segment, what we will do? This is the minor segment. So the remaining part is the major segment. So find the area of the circle and you subtract the area of the minor segment. From that you will get the area of the major segment. So area of the major segment equal to area of circle minus area of minor segment. So area of circle is 3.14 into 15 into 15 minus 20.4375 is equal to 706.5 minus 20.4375. We will get 686.0625 centimeter square. This is the area of the major segment. Now seventh one. A chord of a circle of radius 12 cm subtends an angle of 120 degree at the center. Find the area of the corresponding segment of the circle. Same way, we have to find out this area of this minor segment. What we'll do? We first do the find the area of minor sector and find the area of the triangle and subtract. So area of the minor sector equal to theta by 360 into pi r square. Substituting and solving, we will get 150.72 centimeter square. So this is the area of this sector. Now find the area of the triangle AOB. Here 120. So 120 dividing this OM, draw OM perpendicular to AB. So in triangle AOM, in triangle OAM, in triangle OAM, cos 60 equal to OM by OA. Here cos 60 equal to OM by OA. You know the value of cos 60, it is 1 by 2. So 1 by 2 equal to OM by 12. OA is 12. The radius is given. So OM equal to 6 centimeter. So we got the height as 6 centimeter and it takes sin 60. Then sin 60 equal to AM by OA. So sin 60, the value of sin 60 is root 3 by 2. It's equal to AM by 12. So therefore AM equal to 6 root 3. Therefore AM we got it as 6 root 3. We need AB, that means 2 AM, it's equal to 12 root 3. So we got height and base. Height is 6 centimeter and base is 12 root 3. Then you substitute in the area of the triangle AOB equal to half into B into H, half into 12 root 3 into 6. We got it as 36 root 3. Here the value of root 3 is given. So you substitute that value and solve. So multiplying with the 1.73 we will get 62.2 28 centimeter square. So we got the area of the minor sector and area of the triangle. So to get the area of the to get the area of the minor segment, you subtract the area of the triangle from area of the minor sector. So when you subtracting, we will get 88.44 centimeter square. So this is the area of this part. That means area of the minor segment. Now next one, 8th. A hose is tied to a peg at one corner of a square-shaped grass field of side 15 meter by means of a 5 meter long rope. Find the area of that part of the field in which the hose can graze. Increase in area. Find increase in area if the rope were 10 meter long instead of 5 meter. So here a hose, it's tied on this corner and the length of the rope equal to 5 meter, and our question is how find the area that the hose can graze. So this area, that means this is a sector and this angle is 90 degree. So and the length of the rope 5 meter is taken as radius. So radius is 5 meter, theta equal to 90 degree. So we can use the formula 9 theta by 360 into pi r square. Here theta is 90. So 90 by 360 into pi r square. 1 by 4 into 3.14 into 5 square equal to 19.625. 19.625 meter square that the hose can graze if the length of the rope is 5 meter. Now, if the length of the rope is increased by 10 meter, then how much area the hose can graze? For that, we use area equal to theta by 360 into pi r square. Here, radius equal to 10. I told you, if the length of the rope is increased by 10 meter, that means radius became 10 meter. So, 90 by 360 into 3.14 into 10 into 10. After simplification, we will get it is 78.5 meter square. And here second part is increase in area if the rope were 10 meter long instead of 5 meter. That means you have to find the difference between these two areas. So 78.5 minus 19.625 is equal to 58.875 meter square is the difference between both area. Ninth one, a brooch is made with a silver wire in the form of a circle with a diameter 35 millimeter. The wire is also used in making 5 diameters which divides the circle into 10 equal sectors as shown in the figure. Find the total length of the silver wire record. Find the area of each sector of the brooch. So, here a brooch is made with a silver wire in the form of a circle with a diameter 35 millimeter. And here the wire is also used in making 5 diameters. 5 diameters means this 1, 2, 3 and 4 and 5. The wire is also used in making 5 diameters. So here this wire and this 5 diameters also is the wire. So using that wires it made this outer part and these 5 diameters. So our first question, the total length of the silver wire required. Total length means find the circumference of the circle. This length and this 5 diameters. This is the total length. So here diameter equal to 35 millimeter. So radius of the wire, that this diameter is the diameter of the wire, not the circle. So this is the diameter of the wire. It's equal to 35 millimeter and radius equal to diameter by 2. It's equal to 35 by 2 millimeter. And so the circumference, or this outer length equal to 2 pi r in equal to 2 into 22 by 7 into 35 by 2 equal to 110 millimeter. And one thing is diameter is these 35 millimeter is the diameter of the circle. So diameter of the circle is 35 millimeter. So the radius equal to 35 by 2 millimeter. So circumference equal to 2 pi r equal to 2 into 22 by 7 into 35 by 2 equal to 110 millimeter. So we got this. Now there are 5 diameters also. So 5 into 35. Diameter is 35. So 5 diameters. So 35 into 5. This is equal to 175 millimeter. So the total length of the wire used equal to 110 plus 175, 285 millimeter. Now our second part is the area of each sector of the brooch. So we have to find out the area of this each sector. So when here there are 5 diameter, means it divides the circle into 10 equal parts. That means the complete angle, we know that it is 360. When you divide 360 by 10, we will get 36. So the angle of one brooch equal to, each sector of the brooch equal to 36 degree. So the one angle is 36 degree. So the area of this sector equal to theta by 360 into pi r square, it's equal to 36 by 360 into 22 by 7 into 35 by 2 the whole square equal to 385 millimeter square. Now 10th one, an umbrella has 8 ribs which are equally spaced. Assuming umbrella to be flat circle of radius 45 centimeter, find the area between the two consecutive ribs of the umbrella. So when you flatten an umbrella, it looks like a circle, and its radius is given that the radius of that circle is given as 45 centimeter, and find the area between the two consecutive ribs of the umbrella. So we have to find out this area, and we know that the radius is 45 centimeter. And what about the angle? Here the circle is divided into 8 equal parts. So to get the angle, you divide 360 by 8. So 45 is the angle between two consecutive ribs. So to get the area, use the formula area of the sector theta by 360 into pi r square is equal to 45 by 360 into 22 by 7 into 45 into 45. So we will get 22,275 by 28 centimeter square. Next one. A car has two wipers which do not overlap. Each wiper has a blade of length 25 cm sweeping through an angle of 115 degree. Find the total area cleaned at each sweep of the blades. Here radius is 25 cm. That means the length of each blade, and angle is given that it is 115. Find the area covered by each sweep one by one wiper. For this is we will get when we think we know that this is makes a sector. So the angle made by this each sweep is 115 and radius is 25 centimeter. So by one wiper it is equal to theta by 360 into pi r square. For two wiper, 2 into theta by 360 into pi r square. So 2 into 115 by 360 into 22 by 7 into 25 into 25. It's equal to 1,58,125 by 126 centimeter square. Now 12th one. To warn ships for underwater rocks, a lighthouse spreads a red colored light over a sector of an angle 80 degree to a distance of 16.5 km. Find the area of the sea over which the ships are warned. Here it is given that the lighthouse spreads a red colored light over a sector of angle 80 degree to a distance of 16.5 km. So here 80 degree is the angle of sector and the distance of 16.5 km, it is the radius of the sector. So 80 degree is the angle of sector and 16.5 km is the radius of that sector. Find the area of the sea over which the ships are warned. So here theta 80 degree, radius is 16.5. The area of the sector, we know the formula theta by 360 into pi r square. You substitute and solve, you will get 189.97 km square. 13th one, a round table cover has 6 equal designs as shown in figure. If the radius of the cover is 28 cm, find the cost of making the designs at the rate of rupees 0.35 per centimeter square. Here use root 3 equal to 1.73. So this is a shape of the table cover, has six equal designs. This design, 6 equal designs, and find the cost of making the design at the rate of rupees 0.35 per centimeter square. So here the radius is given as 28 centimeter and the angle is given, it's not given, but here 6 parts. So to get the angle, you divide 360 by 6, you will get this angle is equal to 60 degree. So theta equal to 360 by 6 equal to 60 degree. Now what about this? This is a sector, minor sector. Our question is find the cost to make this design. So first you find the area of this part. So in the previous problems we found that the area of this is a minor segment. So to get the area of the minor segment, first you find the area of the minor sector and then find the area of the triangle and you subtract it. Same way you can do. Here it is. This is angle 60 degree and this is 28 and this is 28. Now this is 28 and this is 28 and here this is 60. So this we know that this is an equilateral triangle. Then you can use the formula root 3 by 4 a square, or you can follow the previous method. That means to draw OM perpendicular to AB. In triangle OAB, cos 30 equal to OM by OA. So OM equal to 14 root 3 and sin 30 equal to AM by OA. So AM equal to 14. So here AB equal to 2 into 14, it's equal to 28. So we got AB also 28. From this we can understand this is a equilateral triangle. Otherwise also we can understand this is an equilateral because it is given that a regular hexagon. The hexagonal shape, equal designs are it's given. So it's a regular hexagon. So all angles are then in this triangle all angles are 60 degree. So it is an equilateral triangle. You can use that method or this method. So here we got AM equal to 14 and AB equal to 28, OM equal to 14 root 3. So before that you find the area of minor segment. So this is equal to theta by 360 into pi r square, 60 by 360 into 22 by 7 into 28 whole square. So 410.67 centimeter square is the area of the minor sector. Now to get the area of the minor segment, area of the minor sector minus area of the triangle, I told you using this method we got area of the triangle is equal to 333.2. So to get area of minor segment, you subtract, we will get 77.47 centimeter square. Now we got this part, but there are 6 such designs. So you multiply this by 6, we will get 464.82 centimeter square. And to get the cost, you multiply that total area by cost per centimeter square, we will get 162.68 rupees. Now 14th one, our last question. Tick the correct answer in the following. Area of a sector of angle P in degree of a circle with radius R is. We know that area of sector is equal to theta by 360 into pi r square. Here the angle is given as P and radius is big R. So theta by 360 into pi r square we can write as P by 360 into pi big R square. Now here this is 2 pi r and this is 2 pi r. So you leave that, and here you check. Here when you multiply both numerator and denominator by 2, we will get P into 2 pi r square by 720. So this is our answer. Option D is correct for the formula for area of sector of angle P. Okay students, thanks.